Good morning, good morning. Welcome to Phase 2 of Power Forward that we have titled Exploring Technologies. I'm so grateful to the folks in the room who are able to attend. We've got a pretty full house here, which is wonderful to see. And also welcome to the millions watching at home via webcast. And that is not fake news. I just received that statistic, just hit my desk just this morning. So very, very pleased that the millions are watching. So thank you again for your attendance and for your interest in Power Forward. This particular phase is going to be, I think, unique for a state commission. This is going to be a very, very deep dive into the technology that we believe is necessary to advance what we saw in Phase 1. So a very quick, just bullet point review of what we saw in Phase 1. First of all, we got a nice little primer of what the Department of Energy and the labs were doing in the grid modernization space, and this is activity that it was wonderful to hear, because this is activity that is actually happening right now, and it's up to the states to be proactive in trying to move the ball in the grid modernization space. We effectively heard about different definitions of grid modernization, what some of our national organizations are doing, and then we heard about what I call the changing consumer sentiment. This is important to build the business case, frankly, for what we're doing here. Why would we do this? Why are we spending our time and our energy looking at this concept of grid modernization? Well, because consumers are changing on a day-to-day basis, and they're changing both in terms of demographics and how they view their service providers. I think that was the different consumer segmentation pieces, what consumers expect from their service providers, especially now their utilities. I think was a wonderful revelation, and I think it very much helped to build the case for why it's necessary to advance in this space outside of what I think we all are here to do, which is to better the lives of customers at the end of the day. I think we also got a very nice glimpse of some of the shiny objects that exist out there. Some of those applications that are real-world applications that consumers can take and better their lives or their businesses. We spent a lot of time on the back end of Phase 1 looking at that. So the combination of these three things, the notion or the fact that this is happening, and that there are organizations that are looking at this, and it's for the states to chart their path, the changing consumer sentiment, and the actual real-world applications provided for what I thought was a wonderful phase. Everybody wants to talk about the marketplace. Everybody wants to talk about the marketplace that's going to be created. We collectively have felt like that's not the right approach to talk about the marketplace before we talk about what is physically necessary on the grid, what is physically necessary to create that great future that we saw, that we got a glimpse of in Phase 1. And that's what we're going to do here. I think it'll be a unique conversation, frankly, for a state PUC. It doesn't really involve policy, and it doesn't really involve rate making. So we're totally out of our element, but we are going to try and get in the element, because we believe that this conversation is absolutely necessary in order to have the third conversation, which is the rate making regulation marketplace conversation. So with that, welcome to Phase 2. We look forward to a wonderful 3 days. I'm going to turn things over to Vice Chair Beth Trombold, who has been leading our internal staff team here at the Commission, has done a brilliant job doing that. Beth?
Thank you. Good morning. Just a couple things I wanted to go over. I wanted to piggyback on some of the chairman's comments, and then also just talk about a little housekeeping things. first of all, a successful grid modernization discussion like Power Forward can't be created overnight, and it's been truly a team effort here. We have a lot of staff who've worked on this to make these phases all possible. And as many of you know, we began by researching what other states are doing and then putting together our plan as far as phase 1 and 2, and then 3 sometime later. Phase 1, which was held in April, we learned a lot of things, as the chairman said. And just to be a little more specific, I went back through my notes of the things that I heard, and these are some of the things that keep running through my head. We heard that smart grid, integration is a journey, and we need to walk, jog, run. So I really like that concept of walk, jog, run that we talked about last time that Paul DiMartini kind of teed up for us. We also talked about how a modernized grid has a lot of definitions, and thanks to Jeff Taft, it has a lot of ILID words, which I think is quite creative, talking about ILID, reliability, affordability, stability, all those types of things. We talked about customer choices at home, at work are shaping the need and pace for grid modernization. And the examples that were given were things like Uber and Netflix. So kind of making those same leaps as far as your electric usage. We talked about the fact that the customer is always on and always connected. So there's this feeling that the grid needs to be available 24/7, perfect power, as I've heard it called before. Terms we were asked to consider, which we're going to explore a little bit today, are things like data. Utilities are becoming rich in so much data, and the software applications being created, and it's driving the online world. So that's one big area. Convergence, the IT, info technology, and OT operational technology, adding value by combining networks. And today we're going to talk a lot about that communication side of telecom and voice, data, video kind of intersecting with the electric world. Interoperability, the grid needs to have characteristics similar to an app store, which I thought was kind of a neat analogy. And then finally, the grid platform, which Jeff Taft is going to lead off and talk a lot about today, to create this ecosystem of consumer products. So with that, I just wanted to recap and then lead into a couple housekeeping things. So as we did last time, this whole 3-day discussion is going to be webcast. It's brought to us by our OGT, Ohio Government Television. They're sitting over there, and we can't thank them enough for their willingness to help us out and make this possible. We want to stay in sync with our agenda as much as possible. So we've asked our speakers to really stay on task in the time periods allotted, and we have time cards for that. And so we're going to try our best to stay according to the agenda that you have there. We have a Wi-Fi username and password. It's up on the screen. I think you can take a look at that. Ohio Guest. The password Ohio is great, with spelled OHISGR8. And live technology has helped assist us with increasing our mic ability and our lighting. So hopefully you can hear. Can everyone hear me in the back? Is the volume good? Okay, great. We also have a workroom just around the corner here. If you need to step out, make a phone call, or do anything, there isn't any webcast ability in there, so you won't be able to hear us necessarily, but you can have a place to go if you need to step out for a bit. The restrooms are right down the hall and on your left, if you need those. And social media, if you want to promote this outstanding event, which we know it's going to be, please use the hashtag PowerForwardOH, and we'd be glad to have that.
There have already been millions of tweets. That's another stat that just hit my desk.
Late breaking news. And then agenda breaks. Just like during phase 1, we have built-in lunches and breaks and networking time. We also ask that you be prompt because, like I said, we want to stay on schedule. And then on Wednesday, we're going to be having our regularly scheduled commission meeting at 1:30. So lunch will be a little extended for that day, but otherwise we just have a 1-hour break. And lastly, we couldn't have this day possible without a number of staff people helping us. And areas of the agency. So I'm not kidding when I said a lot of areas of the agency helped put on today. I want to thank our Office of Public Affairs, our Service Monitoring and Enforcement Department, our Rates and Analysis Department, the Legal Department, and our Business Resources Department. More specifically, there was a really core team that put together today. And Christina Schaefer, who's sitting right here on the end, needs to be commended immensely for all the work. I know all the speakers had interaction with her, and we couldn't have done this without you, so we so appreciate. In addition to all of her workload that she has, she also added this to it. So as you can imagine, it's a lot going on. I also want to thank Mahila Christopher. I see you out there. Can you stand up? She was really instrumental in putting together our Day 3, our Distributive Energy Resources panels, and really thank you for all the work and effort and time you've spent on that. And I also want to thank Kristen Klingen. Where are you? You back there? Way in the back, my aide in my office. She's kind of the glue that's kept this whole thing together. And if you don't have a good team that works on something, you can really tell in the end product. So I think we've been very fortunate to have such a high caliber group working on this. But in addition to the three of them, we also have Marianne Townsend, who's sitting up here at front. She is our expert on telecom, and she was also helpful in putting together today's panel. So Marianne, thank you. We also have Tim Benedict and Nick are, I always do this. Jake Nicodemus. I'm so sorry, Jake. Where are you guys? Stand up. They not here yet? Okay, here's Tim. Okay, and Jake didn't hear me butcher his name. Okay, thank you both for helping us a lot with Day 2. I really appreciate all that. Let's see, who else am I missing? God forbid we miss somebody. Oh, I want to thank all the aides. So can all the aides stand up? Please. Kristen Klingen, Bethany Allen, John Ryan, Rachel Maines, and our newest aide in Commissioner Conway's office, Andy Schaefer.
Man, you started yesterday. What did you do? What are you... Kidding.
He's going to be instrumental in Phase 3. I just know it, right, Commissioner Conway? Yeah. Okay. So anyway, I think I'm done. I want to thank the invited speakers, everyone for coming, and I think we're done with thank yous. So again, appreciate your patience. So now I want to introduce our first speaker, Jeff Taft. And you might remember he was here last time. He's going to be our bookends for this time. He'll be opening and closing this whole discussion. And Jeff has quite a background and one that's very, very important to this discussion. He's the chief architect for the electric grid transformation at the Pacific Northwest National Laboratory, member of Energy and Environment Directorate, and he's responsible for development and articulation of large-scale architecture for grid modernization. He began working on grid mod area in 2001 and has held smart grid chief architect roles with Cisco, Accenture, and IBM. Hails from the Pittsburgh area, so we're lucky to have him so close to us here in Ohio. And he has a PhD in electrical engineering from the University of Pittsburgh. So Jeff, we really appreciated all your comments last time. I know you're going to do a stupendous job this time. I've seen some of his slides, and I think he knows how to frame this discussion really well. So with that, Jeff Taft.
Thank you, and let me thank the Commission for inviting me back. This is just such an excellent thing that's going on here. I'm happy to participate. What we're going to do this morning, excuse me, is talk about the concept of platform, and I have no doubt that you've heard that word a lot. It's actually probably in the running for the 2017 Electric Industry Word of the Year. There are a couple of other contenders, but nevertheless, this one is up there. And you'll undoubtedly hear it a lot over the next number of days and well beyond that, but it's worth focusing on what it is because it's a very powerful idea. It gets used a lot in a lot of different ways. And so we're going to spend some time talking about, in an abstract sense, what do we mean by platform? And then we'll gradually move toward what does that mean for the electric grid. So hopefully by the time we're finished this morning, you'll have a good sense of this word, and when it comes up, as it inevitably will, you'll have an understanding of how people are using it because they'll use it in some different ways. They're all related. They all have a fundamental underlying concept that's important here, but can be a little bit confusing when people start to throw that past you with a lot of other stuff. So what we're going to do is talk about platform, and we're talking about some definitions and look at a few examples. Then we're going to talk about it as an architectural concept. And this is a little bit technical, but not so deep that it'll be difficult to follow. Then we'll start to move toward what does that mean for the grid, and then I have some comments toward the end about how we'll think about what is core to the grid, what is platform versus what is not platform. So here's some typical definitions that you would find if you look for this. And the one that we'll focus on first is the ordinary one that comes from a construction, a raised level surface that people can do things on. We're going to start with that because that really helps us get a good grasp of the idea before we delve into a lot of the esoteric aspects of software and so on. But you'll find this used in a lot of industries. In the automotive industry, they'll talk about the basic frame and structure that they might share across several models of cars as being the platform on which they build different cars, and use this all the time in the information systems industry in computing systems. And I'm going to talk about that in a little bit because there are a couple of interesting lessons that come out of how it's applied there. It can be a set of tools. For example, in the digital publishing area, they'll talk about the collection of tools that they use as being the platform for doing publishing. So you can see that there's different views about what constitutes platform depending on exactly what you're doing. And the one at the bottom that's sort of very general that you'll find is a set of components or services that creates a common foundation. And that common foundation issue is kind of important to remember because the idea is platform is in a sense shared across a number of activities. So let's look at that in starting off with kind of the construction case. So we can have a platform and anybody would look at this thing and say, yep, that's a platform. But notice that it has a number of parts to it. It's not just one thing, it's got different components. And so when we look at platforms in general, as we move toward information systems and the grid, we'll see that those platforms have a bunch of parts to them. It's not just a single monolithic thing. There are also some standards that may be involved. In this case, the way that we build stair steps, there are some standards for the size of risers and whatnot and the heights of railings and so on. So a lot of times platforms also involve some form of standards as well. And we use the same platform to do a lot of different things. So maybe we've got a person giving a speech, maybe we have a band playing on the platform, maybe there's some kind of performance. Through all of that, the platform is the same. And that's going to get to another core concept about platform, the fact that it's essentially constant and yet it serves many different purposes. And a lot of times we will see that platforms have multiple layers within them, and that's kind of an important concept. We're going to talk about why the idea of layering is so important in building complex systems like the grid and the way we're changing the grid. And oh, by the way, in this particular diagram, notice something else. You can see that little red bracket that I marked there. Notice that the ground is not even, and the first layer of that platform deals with the fact that the ground's not even. And then there's another layer of platform on top of that, above the steps there. This is an important idea because if you didn't do something like that, everybody who came in to use the platform would have to deal with that unevenness, and that would be difficult. So by doing this, the platform can even out the uneven things that would make it difficult for people to come in and do what they want to do for applications, can isolate those lower level problems from upper level systems. And we're going to see that a lot in terms of platforms going forward. Why is that important? It has to do with how you do future proofing of investments. When it comes to the grid, this turns out to be a really important issue. So understanding the way the platform can help you future-proof is a valuable thing to do. So let's look at this in terms of computing systems a little bit. So going back a few years to the sort of earlier days of personal computers, we used to see diagrams a lot like this in the engineering world. And we would think of the basic hardware of the computer, the processor, the memory, the disk drives, the communication ports as being a sort of a thing that had a particular shape to it. And every one of these made by a different company, different brand, was a little bit different. And they were difficult to deal with. As low-level technical details of the hardware were very hard for anybody to say, well, I want to write a piece of software to run on this thing, but I got to deal with all those little pieces and parts. So people came along and said, you know what, let's create a little layer to go on top of this. And we called it the basic input-output system. It's a thin layer of firmware, and what it does is it evens out that by taking account on one side all those little variations in the hardware and presenting a more uniform interface above. just like we just looked at that example of the platform where one layer took care of the uneven ground and then the next layer up was a simple, straightforward thing to use, we did that with computers all the time. And so it didn't matter anymore to the people who wanted to write applications what that uneven hardware looked like, because we put a layer on it and made that even. And then we said, well, you know what, that's still kind of not quite there. We need to have a set of services, a set of things that everybody would want to use that we would layer on top of that. So we created this thing called operating systems. Then finally, we got to the stuff that people wanted to actually do with all this. So word processing, spreadsheets, and so on. Now, if you look at this, you would say, depending on your point of view, some level of this is a platform. And remember what I said, the platform kind of evens things out. It's kind of constant across multiple applications. So the applications that you see here will change on short and long time scales. Short means right now I'm using the word processor, 10 minutes from now I might be using the browser. Long time scale means I have one kind of word processor now, maybe a few years from now there's a better one, so I throw away the old one and I get a new one. But I don't want to have to change everything down in the hardware just so I can use that new one. So I get a little bit of an insulating effect there. And look what happens if I change the underlying hardware. Because of the way I've done that, I don't have to worry about changes in the operating system or the applications if I need to change that underlying hardware. So that's that sort of insulating effect that can come about when you think about this in terms of layers, and layering is kind of an important concept when you deal with platforms. Okay, so platform is an architectural concept. That means it's about structure, how the elements are grouped, how they're related to each other. And we separate a complex system into a sort of common set of support capabilities. And notice we keep using words that you can relate right back to the first diagram of that physical platform. Common set of support capabilities, some people will call it foundation, sometimes it'll be called core, from the individual uses, which in the computer world are almost invariably called applications, but sometimes in other kinds of platforms we don't call them that. So we've already separated into two things, foundational elements or core elements, and application pieces. And a platform is always going to relate to the foundational or core elements. And we're going to then be able to put the applications or uses on top of that. So here's a useful definition, and it's generic and abstract because you're going to run into people using the term platform in a lot of different ways over the next few days and over the course of the future. But they always come back to the same thing. Platform is this collection of parts, pretty stable, means we don't change it much. And it provides some capabilities, some services that are needed for a lot of different uses. And that is really sort of the essence of it is. And finally, it needs to have well-defined interoperable interfaces. And the reason for that is you don't want to be stuck with something that gives you kind of a lock-in problem where the only way you can use it is you always have to go back to that particular vendor all the time. And so it's well understood that we have to have this interoperability, this interface capability to be able to use the platform. Any good platform has some key properties, and they're kind of listed here. Now, I already talked about the separation function. Talked about the fact that it supplies a set of services. And we've mentioned the fact that it's stable over time. Usually the platform doesn't change too fast. That also means that some care has to be taken in designing the platform so that it is broad enough that you don't have to continually tinker with it, because the whole idea is that what's in place, you don't want to mess with it too much. We talked about isolation, and something else that we typically want is we want it to be scalable. Now this turns up in the computer field all the time, but it applies in general to the grid, and that means that we're able to supply an adjustable amount of resources to fit the demands of whatever it's being used for at the moment. You'll see that a lot in software-oriented platforms about the idea of scalability, and you'll hear that term come up a lot too. Then, very importantly, we'd like it to be an open platform. That means you want third parties to be able to put things on it. So I will say that in general, the computer industry understands this issue pretty well. In my experience, most utilities are pretty sophisticated about this issue now, about open platforms and the need to avoid some kinds of lock-in. So that's one of the things that you would think about in terms of a platform. Is it sufficiently open that people will be able to do neat things on it, even if they're not things that you have thought about? Because people will think up new applications, new ideas, new kinds of transactions. And you'd like to not have to change that platform, and you'd like to not have to go back to the platform maker to be able to do those new things. You'd like to have third parties do it, because that's how you foster an ecosystem around a platform that allows people to do the kinds of things they want to do going forward. So ultimately, then, the value of the platform is spread across a lot of different uses or applications. And that's kind of important to understand about the investment in these things. And some of those things are not necessarily known at the time that you're selecting the platform. So a well-designed platform has room for that kind of growth. And that can be a little bit difficult to foresee, since we don't necessarily know all the things we're going to be doing. But people who design platforms get reasonably sophisticated about thinking about, how do I make this open-ended enough without making it so generic that I can't, make it useful? Part of doing that involves this concept of layering. And layering, again, is an architectural concept, really important. And you'll see this time and again in the grid going forward. So one of the things about layering is that when we stack up a set of layers, when we have one layer in the middle, like the one that you see there in green, it has this nice property that it isolates changes in the layer below from changes in the layer above it. That's really important for the grid, and we're going to see that later on. The idea is, how do you do future proofing of investment? Well, that isolation effect of multiple layers helps you do that. So if you change the applications, you'd not like to have to go down and change the core infrastructure. And if you need to make a change in the infrastructure, or what happens, you'd not like to have to go back and rework all the applications. This layering effect helps provide that isolation that's been around in the computer industry forever. And you see this being thought about in the grid now, and one of the ways that you see it being thought about has to do with something that Mark is going to talk about after me, and that's communications. How you think about the communications and how that helps you separate things that are applications from things that are core infrastructure is an important idea going forward in terms of grid modernization. Now, sometimes you'll see diagrams for platforms, and you see lots of layers, and you'll see lots of little boxes. We'll look at a couple of those in a minute. But sometimes you'll see them drawn like this thing here, like these onion diagrams. Really popular for operating systems, but you'll see it in terms of IoT platforms and other things going forward. All we did here was we took a set of horizontal layers for a platform, we bent them around in a circle. That's how we made an onion out of it. So the thing that was the bottom layer is now the central core. So that's all this is. This is another common way that you'll see this. It's the same idea. There are multiple layers, and those layers provide that insulating effect. The inner pieces are the pieces that are kind of constant and shared across everything. The outer pieces are the things that vary from use to use. What constitutes a platform can depend somewhat on your point of view. So you'll see platforms within platforms. You'll see that one person's platform is not another person's platform, and you'll see the idea that you may have multiple platforms. So let's look at the computer example again. At the lowest level, if I am writing this BIOS layer that I talked about, the platform is the hardware underneath it. So if I'm the BIOS writer, I say, well, the platform is that piece of computer gear. But if I'm the operating system person, I would say, well, the combination of the hardware and the BIOS is the platform that I'm going to use. And of course, if I'm the application person, I would say it's the whole thing. So you can see that the concept of platform depends on what it is you're doing and what your point of view is. And it's a recursive, meaning it's sort of a nested thing. There's a platform inside of a platform inside of a platform effect that happens here. So when people talk about platforms, you'll have to be a little bit alert to the point of view that they're using so that you get a good appreciation of what exactly they mean by platform and what's included in it. And if it's not clear, it may be helpful to ask them when they talk about, well, it runs on so-and-so platform, or I have this platform, to be clear about exactly what they see as being included in that. So I mentioned, again, what's in a platform. You'll see a lot of diagrams like these, and these are typical examples. You'll notice that some of them have multiple layers. You'll notice that some of them have very general descriptions. The one in the upper right, for example, it just describes general capabilities that are in the platform, where some of them will have a great deal of very specific elements. And remember I said a platform can have multiple elements in it. So typically you'll see this description, and inside the big box or set of layers that represent a platform, you'll see lots of little boxes that are components of the platform. So one of the questions will be, so how do they decide what goes in a platform? This is a really important issue, and it will become an even more important issue in grid modernization when we talk about the grid as being a platform itself. So there are ways that people go about deciding what's in a platform. One of the ways, frankly, is to just do this as an ad hoc analysis. You sit down and you think about all the pieces and you reason about them and say, well, I can see how these pieces are going to be used across a lot of different uses or applications, so I'm going to put that in the platform. And that's done quite a bit. There are more formal methods. There's a method called design system matrix, and that's used in project management, but can also be used to identify in a very complex system those pieces that have multiple uses that you group together and say, okay, on an analytical basis, I will now say that's what constitutes the platform. You'll see this done in some very sophisticated product development organizations. There's another method that we use when we're dealing with a lot of legacy, as we do with the grid, to say, okay, I've got a bunch of things, maybe I've got a bunch of independent siloed applications, and I'd like to think about a platform for them. And so there's a process that we've developed that you can go through to figure out how to identify, how to split apart, how to regroup things. That's what that little silo to layer conversion diagram is about there. I won't go to the details of how we do that, but we've actually used that to figure out how to convert some things that exist in the grid now, which are treated as independent siloed applications, into a combination of applications and platform, so that you can identify those pieces that make sense as fundamental or core infrastructure in the platform, and thereby separate them out from the applications. That particular issue is becoming a lot more important now as we move forward to adding new kinds of things to the grid. So for a long time, we had sort of standard components for infrastructure for the grid, and everybody understood, a power transformer is a core element of the grid, and a transmission line is, and so on. Now we're looking at new kinds of capabilities for distributed generation, for storage, and so on. And so there is a logical question: are any of these things, should any of these things be considered core infrastructure versus just application pieces that are attached at the edge? I'm going to come back to that later on. When we think about the grid, you're going to hear about a lot of different kinds of platforms. You'll hear about them for sensor management and analytics and IoT, grid management. There's a project with the Department of Energy for developing an open advanced distribution management system platform. And that the whole idea is that all of the applications for managing a distribution grid should be run on some kind of open platform so that anybody can write those applications. And they're going to try to do that and make that available to the industry. So there's a lot of this kind of activity. You'll even see people talking about more abstract things as platforms, like a business model instead of business processes sometimes will be referred to as a business platform. So you're going to run into this term time and again. Sometimes it'll seem very abstract, but it's always the same idea. There's a core set of things that are used across a lot of different uses or applications, and those things are fundamental. They provide a set of services. They provide a little bit of isolation from underlying variations. You'll see that over and over again. And you'll see different implementations. You'll see people say, well, I've got a platform that the utility could buy and they own and operate it. It may be in the form of what's called middleware. It may be just a set of servers and software. You'll see people say, well, I've got a cloud-based platform, which means all that stuff resides somewhere else and you basically use it. You may see the term platform as a service. Right? So you see all of that kind of elaboration going on, and you'll hear about that because people are very inventive and innovative about how to apply this concept. And that's a good thing. It gives us a lot of different options. In the DSPX project, we spent a bunch of time thinking about what would be platform according to the set of criteria and objectives that those organizations we were doing the work for had, and you can read about that in the material that's online, but I wanted to show you one of the diagrams from that work. That diagram has two pieces to it with a horizontal gray dividing line that you see there. Below the line is,
Jeff, would you mind if I just asked a quick
Sure,
question before
please.
you get into the
Please.
DSPX project? As you were talking about the platform and the different ways to look at it and as a result define what's in the platform or what's not in the platform, do you find in your experience in doing that kind of analysis that there are instances or circumstances when you can simultaneously have an element which is regarded both as part of the part of the platform, the core, I suppose the core structure, and is also at the same time, and it could be an element or an application, not simply, something beyond the edge of the platform, an element that is simultaneously, in some instances, part of the platform, but in other instances, outside of the platform? Or is that what we're trying to avoid doing?
so that's a pretty sophisticated question. Are you sure you're not an architect? So from a pure architectural theory standpoint, we like to try to be clean about that separation, but it doesn't always happen. You'll run into instances where people will say, I've got a platform, and you'll be looking at the elements of the platform, and then you'll see something that sort of sticks out and see people would use that directly as if it were an application. That can happen. It's not a tragedy if that happens. But we try to keep it clean because keeping it clean allows us to get that isolation effect that gets us a really good way to deal with future proofing of investments.
Okay, thank you. Sorry for the interruption.
Anytime, no problem. This is better as a discussion than a lecture always. So in the DSPX work, we spent a lot of time thinking about what would be core capabilities and what would be applications. And the result of that, which is not intended to say that this is a template for what you will do, I just want to show you an example of how this was done with a lot of ad hoc analysis, but with a lot of being informed by architectural principles. So to understand how we got to this, we didn't use design system matrix and some of that stuff. We did use that silo to layer conversion process a little bit, and you can see that when you read the documents. But the important thing here is, if you look at that diagram, there's a horizontal gray line almost in the middle there, a little above middle, and see the boxes below are the blue and green ones. And that stuff is labeled core. That piece below the line is the platform. The idea is that those pieces would be used time and again for different purposes, and all the pieces above the line are the applications that would be used to manage this modernized grid. If you look at that diagram, you'll see how far down that goes, all the way down to the physical system, all the way down to the physical grid. And so we ended up defining the platform a lot like the way I showed you with the computer, where the lowest layer in the computer was the computer hardware, and then there were several layers above it. Well, here you see the lowest layer is the physical infrastructure, but then you also see communications, and then you see a variety of things that we judged would be useful across many different pieces of what you have to do to manage the grid. So that is platform below the line and applications above the line. So that's one example of having done this for the grid. Other people may come to different conclusions about individual pieces, but I want you to see that as an example. And then this one is also from that same work. It's sort of a pictorial representation of how would we think about all of that and show that in something that gives you a little bit better sense. And you can see the electrical infrastructure is really the bottom piece of this, the bottom layer. And then coming up from that is the communications capability, and up a little bit higher, some of the basic software. So we talked about it as being a cyber physical platform. Cyber meaning the information systems and communications piece of it, and physical meaning the electric infrastructure piece. Off to the side, there's a market platform, because in that work they were interested in a market mechanism. That doesn't have to be there. That's just the example of what they wanted. And then you see pieces that are actually the operational aspects of both planning and running the grid, to kind of the application pieces. So where you draw those lines is important, because that will tell you a lot about how you want to do the treatments in terms of how should things be paid for. How should they be invested in? And when you start to think about the things that you do as a commission, those questions are going to come up, and people are going to ask the question or suggest one way or another, what is core infrastructure versus what is not core infrastructure, and then what should the treatment be? And I think that is starting to be a really important issue across the country in terms of certain technologies in particular. So another view of that same thing, you can see here the distribution platform, again, is the physical infrastructure. Communications, in this case, sensing and measurement is part of that as well. And you can see the individual applications there. There's a particular way of doing this that makes this an interesting case for how to think about investment and so on in the grid. But that's something that is yet to be fully determined. We've traditionally thought about core infrastructure in the grid, but we increasingly have these new kinds of capabilities, new kinds of technologies, and the question is, should any of those be thought of as core versus not? And we'll come back to that later on. I'm going to make remarks at the end of the 3 days here. I want to talk about that some more at the end, but I would prefer that you hear from all of the excellent speakers that you have lined up before we do that. So just let me sort of wind up here by saying, we've talked about platform as an abstract idea. It's an architectural idea. And there are lots of different ways that it can be used and lots of different ways that it is used, and you're going to hear a lot about that in the coming days and going forward. The idea is to separate the core stuff from the applications. That has value in terms of the way that we do the investment. It has value in terms of the way that things are made useful and the way that you separate things that are underlying from things that change a lot. That is just a really useful concept, and we use the concept of layering within that to help do that. We can look at the distribution system as a platform, and that is happening more frequently. That means that we have to start thinking about what are going to be core components in that platform, and therefore core infrastructure, and what are not. As I said, when I come back on Thursday, we'll talk some more about that, in particular with regard to some kinds of classes of components. But I think that's one of the most important things that you'll have to sort out going forward, is what's core and what is not core, and then how should it be treated in the sense of the kinds of decisions that you all make. So let me stop there and see if you have some questions for me.
Jeff, thank you very much. Wonderful presentation. I think let me turn to Commissioner Friedman first to ask you a few questions, and we'll move on down the line.
Thank you, Chairman. Mr. Taft, thanks for coming. It's thought-provoking, to say the least, and challenging, at least for me, to understand. I've been wrestling, frankly, over the last couple of weeks since the first session we conducted, in terms of the definition of a platform, because we all, as you have pointed out today, have different ideas and concepts associated with that. But I think one of the universal premises is that there are many, many touch points along the grid as it relates to platform development. I mean, it's at the consumer level, it's at the distribution level, the transmission and the generation level. As you conceptualize a platform, do you see it as a single and seamless foundation that crosses all of those touch points, or do you see it as multiple but compatible to provide the necessary continuity of informational flow?
Boy, really good question. It would be great if we could do the former, but we probably can't really get there for a whole bunch of reasons, some of which are technical and some of which are otherwise. So as a practical matter, we'll see a lot of platforms, and they'll exist in those different domains. There should be, and it's up to all of us to make sure that there are elements of interoperability across those platforms. So when you hear about interoperability and interfaces, interoperability among platforms is one of the many ways that we have to think about that. There are other dimensions to interoperability too, at the device level and so on. But with all these different platforms that you'll be presented with, and almost certainly the utilities will have more than one that they will need, because there's not one grand and glorious platform, you're going to see a lot of this kind of problem and a lot of this issue. So the interoperability thing is always important to watch for. At the distribution level, people are starting to think about treating the grid itself as a platform. And in that sense, your idea about the former kind of view within the domain of distribution is a little bit more feasible. So you may know that the three investor-owned utilities in California have each declared that they want to transform their distribution systems from being a one-way energy delivery channel into being an energy transaction platform across which any qualified participant can carry out things. So if you take that point of view that your distribution system is a platform for energy transactions, that will tell you a lot about the kinds of changes you would have to make, both physical changes and changes in business models and even regulatory issues, right? So it has profound implications if you decide to go down that path. And I think that we'll probably see some of that happening because the way that things are moving in many parts of the country with things like microgrids and community solar and so on, it makes more sense to say that maybe the distribution system is not strictly a one-way energy delivery channel anymore because it's not the only way to obtain energy. And so its value can be sustained or even increased if it's thought of as a platform as opposed to being that old-fashioned energy delivery channel. So I think in that case, you would see a more nearly unified concept of platform across the distribution domain. Doing it all the way across from generation and so on, maybe in the long run, some of the discussion about distribution system operators and some of that is getting at moving in the direction of sort of unifying transmission and distribution. There's a tendency for those to become integrated going forward. So it could happen, but it's probably not going to happen first.
Thank you. And just one more follow-up, if I can. Consistent with your comments relative to layering and your comment relative to independent third-party access to platforms, and again, the definition of what is a platform, we each have our own ideas. That is distinguishable, I think, access from ownership. So in your mind, if there is the underlying compatibility of platforms, the ownership is multiple? I mean, there is no singular owner of well, the pyramidal platform after all the layering is done?
The part that we would call platform, that sort of fundamental piece, very likely has a single owner, although it's possible to envision other models. The applications that reside upon it may end up with a single owner, the owner perhaps being the utility, or not necessarily, but certainly they may come from different creators of those as well. So there's lots of room for innovation in terms of whether they're owned by multiple parties or whether they're created by multiple parties. So if you look at the entire set, the entire stack of platform plus applications, then I think the multi-owner model is entirely feasible. The platform itself, I suspect that's going to tend to be a single owner. The owner may be the utility, it may be not. In the case of platform as a service, it may be a third-party company that makes a platform available and the utility uses that as a service. So the ownership may not be the utility, but it's still going to be a single owner in a case like that.
Thank you very much.
Thank you very much, and thank you for your presentation. I just wanted to, in talking about the platform and talking about the modern grid, I need to understand a little bit more about where we are right now. I mean, from your description, couldn't we say we have a platform now? And but what will it take, or what? I mean, just in a few words, how do we get to the modern grid, the modern platform?
Well, that's a big question.
Well, it is a big question, and I know there's other people going to be talking about it, but kind of explain to me how I can understand where we are right now.
So the way we have operated our grids now is especially at the distribution levels, they really kind of have a single dedicated purpose, and that's the delivery of electricity at the local level. They're not really open to much of anything else. And there are good reasons why it evolved that way, so that's not a criticism. But if it's going to become something that's more nearly like a platform, says that it will become more open, as I mentioned, to perhaps various kinds of energy transactions. So what a platform does is, in addition to the isolation and layering and all that kind of stuff, it provides a set of services and a set of functions that can be used by a lot of different applications. And so that would imply, in some manner, opening up the way distribution is operated to more parties to carry out different kinds of energy transactions I was mentioning. That has a lot of implications for the physical infrastructure, the way protection and control is operated in particular, but maybe even the way the basic wiring is done. It has implications for the business model of the utility, and it has implications for the interface requirements, and those probably lead to more questions about the nature of regulation in an environment like that, where you have more people using something where you used to have a single organization that built it, operated it, maintained it, had the responsibility for reliability. And now you have many participants using it as if it's a common set of services. And so there's a lot to be thought through, both in terms of physical changes and in IT type systems, but also in terms of business model and even regulatory issues before we actually arrive at that point. So it's a pretty big thing that has to change there, and some of that is inevitably going to involve the kind of work that you folks do.
Jeff, let me try, excuse me, let me try and bridge the question and your answer there. Let's take a look at your slide 16. I think, Tom, I don't want to put words in your mouth, but I think
I can't see the numbers, so I'm
Okay, sorry, it is your DSPX.
That one?
Yeah, it is your DSPX project distribution system platform. I think, and this would have been a question of mine as well. Generally speaking, when you put this particular slide together, what was your understanding of where, just broadly, the electric utilities sat within this diagram right now? Meaning, they've got the physical grid infrastructure, whether or not it's prepared or not yet for the next thing, we don't know. We'll actually hear from our utilities over the next few days. The operational communication. So, what's your general understanding of where utility infrastructure and capabilities sits today?
So all of the stuff that's below that horizontal line, we certainly think that in this case that would all be utility components and capabilities.
Current or under development or
Well, some of that, especially at the lower levels, is current.
Right.
Right. So the physical infrastructure, there's communications, although that may be evolving and so on. You would find in most utilities, some of those blocks are in existence in the utilities because they need them already. They may not be organized quite this way. They may be grouped into siloed systems and so on, but you'd find some of those capabilities. Moving above the line, you would also find some of those capabilities, but again, not organized in this particular fashion. And there are some things on there that you would not find at all presently in utilities. For example, as you know, in this project, there was a presumption that there would likely be distribution level markets for distributed energy resources, a presumption that doesn't necessarily apply here. But for those folks, that was a presumption. So you would see elements in there that are about that. And those don't exist today at all, for example. And so what we were looking at is over the next 5-year time horizon, what sort of things would be necessary to enable the goals that those organizations had, and then what would the platform look like to do that. So the idea is that all of this would end up being utility capabilities down the road, but certainly not all of this exists today, and not necessarily in the form that we organized it here either.
Very good. Yep. Beth?
Just to follow up, so could you talk a little bit about best practices and what you've seen in other states? I know, a lot of this is still relatively new or maybe not in practice yet, but could you talk a little bit about, below the line, what you've seen or what you think is workable?
So this is very much evolving, and a lot of the activity these days that we see is around the communications, and I won't go too deeply into that because Mark is going to talk about that next, so he'll give you a good view about that. But there's quite a lot of focus on how the communications at the distribution level should work to enable this kind of a future. Very important issue because most people have begun to realize that that really should be thought of as core capability associated with the infrastructure, as opposed to, in the past we had a lot of communications that were siloed because they were associated with a particular application like AMI or SCADA and so on, and that view is changing a lot. As far as the rest of it goes, the utilities that are sort of leading the charge in this area, the states that are very much trying to figure this out. This is by no means settled. So to say what are the best practices, we know that there are some basics. Interoperability and open standards are always best practices in this work, and you'll see that referenced a lot. Thinking about what should be core and what is not, there's a great deal of effort going into that thinking now. This is only one example, but it's not the only ones. So I would say that you can count on those two things, open standards and interoperability, being always the case. The restructuring of all of this is new area for the utilities by and large. You will hear a lot of people who are going to come and say we have platforms for these things, and they do. But in terms of the industry converging, well, you probably know at the distribution level, there's never been a lot of that kind of convergence anyways. And it's certainly not in this case when this is being so new. So I wish I could give you a long list of best practices, but I don't think they're quite there yet. Some other folks may have different views about that they'll offer over the next few days, and that'll be good too.
Mr. Conway?
Thank you very much, Jeff. In my experience, when you're trying to address problems and issues, you're best served if you pick a point of reference, some sort of system to use to evaluate the issues and the problems. And I think what you've done here is provide us with a point of reference, a means to rationally, logically address the issues that we're facing. So I really appreciate it. I think it's very helpful. I also think your question, Mr. Chairman, about slide 16 was right on point. The question that comes to mind is, how do we look at currently where the line is drawn and where in the future it might be drawn, as far as what's part of the core structure and what's perhaps outside the core structure. So
yeah, I would say that is a very key question for the proceedings that you have here and likewise in other states. When I talk at the end, I'll say a few more words about some views I have about that, but I'd like to save that till after you've had a chance to hear from all of the speakers, because I think there are some items in particular that really deserve some special focus in this regard. But rather than sort of box anybody in, I'd like to have them speak first, and we'll talk about that again on Thursday.
Great. Jeff, so I want to take a little time and separate the definitional facet of the platform and talk about just purely the infrastructure elements. And so with respect to slide 16, below the line, is there general consensus that these are the core components as it exists today that comprise the modern grid platform?
No, I would not say that's true. This work, as you know, is very recent, and as we did the work, we consulted a lot with people from across the industry. So there were specific jurisdictions that we were doing this for, but we didn't limit ourselves to just talking to those commissions, for example. We did a lot of review with people from the industry. That means utilities from across the country, vendors of various products. We talked to university people. There was an enormous amount of stakeholder input that we gathered in doing this to assemble this view. This view didn't exist before that. And while there are certainly, you can find work that people have opinions about how the modern grid should be structured, I would not say that there was a consensus about that, and I would not say that this is necessarily the consensus view either. We think we did a pretty good job on this, given the targets that we had in mind. And remember, there were specific things that people wanted to do. But I don't think you could look at that and say that's the answer that everybody has arrived at yet.
Okay. And some of these are actual, some of these are physical infrastructure related, things that you can actually touch, install, etc. And some of these are actions to be taken. And so with the core components piece, you paired power flow analysis, you paired actual action with the actual physical components. And so you paired what you thought was necessary from an activity standpoint with the actual infrastructure.
Yeah, so remember when I talked about platforms, I said that the components that are in there are intended to supply a set of services to the various applications. So power flow analysis is like that. I mean, there's physical stuff, there's software that you use to do that, right? So there are things that are, in a sense, tangible as software is, that you would have, and the utility would say, I have a power flow analysis package. And it sits here, it runs on this computer server, so in that sense it's tangible, but it's really being used as a service to support these other activities that are above the line. So if you think about that as the components necessary to provide the set of services that you want your platform to support, maybe that helps a little bit with the visualization of what that is. So in a sense, you're right, there's an activity there, the activity is supplying that service, but underlying that is something that people would actually invest in.
I'm trying to view the end game here with respect to this discussion, which has been extremely helpful, of course. I'm wondering what do you think makes more sense? Do you think it makes more sense, A, to try and call out the actual pieces of the core components? Do you think it makes more sense to create a broad definition for what you believe the core components, synonymous with platform? Well, actually not synonymous with platform, it's a portion of the platform, sorry. So do you think it makes more sense to define what you think define the core components, because we don't know what we don't know, and that items could drop in and out of the core components realm? Or do you think it makes more sense in sort of divvying up this world to define applications and say, if it's not an application, because that feels easier from the layman's perspective, that feels easier. If it's not an application, then it's a core component, and that's then part of a different realm of the platform.
I don't think I would attack it exactly either of those ways, but that's me, Mr. Architect, right? We have some ways of being somewhat analytical about looking at pieces of this and saying this is core or not core. And I sort of, referenced a few of those earlier on. Some of those methods are a little bit technical and some of them are not so technical. I wouldn't take this and say, well, if I can't clearly say it's an application, it must be core. I think that can lead to some difficulties down the road. So I wouldn't be that straightforward. It would be nice to be, because that seems very clean. But I can envision how that could run into some problems, and you would run into some clashes with people offering things and saying, well, no, you said that that's an application. I think it's core, or vice versa. So I think that what you want to do is think about what kinds of things fit the category of being core or platform, and some of those characteristics it has to have is it's not expected to change very much. It's useful across a lot of different uses. It supplies some kind of service capability. Those are kinds of things I would look at and say, can I think of this as being core or not core, versus those criteria. And as far as picking specific things and trying to classify them, I think that there are going to be times when you're going to want to actually think about that. And again, it'll be in versus those criteria, but you'll be looking at a particular thing and saying, does it fit these criteria or not? Not that you should go through and try to classify everything that be related to the grid as being one or the other.
So you could have a hybrid approach where you classify certain things as being core because you feel like that's necessary to advance the grid, and then leave others potentially subject to future interpretation or future discussion.
Yeah, but based on, hard reasoning, not
Right.
just sort of
Right.
intuitive, but we would have reasons why we think it's that. So yeah, I would suggest that you think about it that way, because I know that there's enough complexity in all of this, and you're going to hear enough from people who are offering either applications or platforms or both, that if you sort of try to get into the business saying, I'm going to decide what's what, that's going to probably result in a lot of back and forth. I don't think you have to do that. I think that some things are very clear, You know, I think we know a substation is in fact core infrastructure. We don't have to talk about that. I think that some of the newer things that are coming along are where you're going to have to treat that in a little bit more special case kind of thing and look at them and say, how would this be used? And does it supply a service, or is it more like an application? And how does it need to be treated? So I would say that's what you have to do. Yeah.
Thanks. Commissioner Conway?
Just to follow up on that line briefly, Jeff, would you think that it would be possible, maybe reasonable, to include as a factor in determining what's core or not core, whether the element is scalable rapidly, and whether or not there's one or, there's one stakeholder or participant that's more able than another to actually deploy it in a scalable fashion?
Okay, so there are two questions there,
Well, I'm
which is
thinking about-
okay.
Yeah, I mean, just to, not to talk in generalities, the meters that you've got above the line.
Yeah.
You know, in Ohio, we're already embarking on a path of deploying advanced meters, smart meters. And the utilities are doing it. And I'm not, and my intuition is that that's the right thing to do, but you have it above the line.
Yeah, that has to do, and if you want to see more about that, all of the documents for this are available online. There's a lot of explanation of why we did that. But when we looked at those things, we tried to figure out, so what stuff is useful in multiple ways, what stuff supplies a service to a lot of different capabilities, and what is sort of very particular and peculiar. And that's how we ended up with the categorizations. And it was versus the set of objectives that those jurisdictions had too. And that's why I want to emphasize this is not necessarily the answer you would have, because your objectives may not match that. And I will say that because we did this with that kind of reasoning, it would not surprise me if someone else looked at this and said, well, I might want to nitpick and maybe this box doesn't belong here, it belongs there. We did a lot of review on this, and this was a result of what we got for the review, but it's somewhat ad hoc. This isn't, unfortunately, an exact science. If we wanted to be really exact about this, we would go and look at one of those methods I showed you, like the design system matrix stuff. Really complex, hard thing to do. And you could get answers that way, and you could point to them and say, well, there was a rigorous approach and we got this answer. People would still argue with about the answer when you got it. That's what happens. So you're going to have to think about that in the context of what you are faced with here in this state, I think, to decide which things fit above and below the line. That's right. And that's going to require some deliberation, some thought, some expert opinions, and so on. It's not as rigorous as we would like it to be. I wish I could say we can set up a formula and we can solve the formula and it'll tell us the answers. I love stuff like that, but this isn't one of those things that's that science.
Outside of thought, you forgot to mention criticism, articles, pain, all of that.
All of that, but
right.
You know better than me.
Right. Commissioner Johnson.
Thank you. So when I look at the platform, and we're in sometimes called a competitive state, Pennsylvania also. And when we look at the non-competitive states, does the platform look any different in your eyes?
I haven't thought very deeply about that, but my initial thought is not very much different. You might argue a little bit about individual boxes sort of being above the below the line in a diagram like this, but really the way we outline this in terms of principles is what constitutes a platform. And when we thought about that and the way I described it here, it wasn't in reference to any particular industry model or regulatory regime. So I would say probably that doesn't make too much difference. I would expect it to be sort of marginal changes.
But the marketplace will be different, likely.
Yes.
Because there are fewer players.
Yes. But when you think about the utility and what they need to have as a platform to enable a certain set of capabilities, you go back to these sort of fundamental definitions and so on. And I think that that'll play out in a similar way.
Christina, questions?
We're going to talk about this a bit. Everyone hear me? Later this afternoon on the integration.
Still no mic.
I think you have to turn the switch on there, yeah.
That was
Have
the
to
best
turn it
advice.
on?
That was the best advice Jeff Taft gave today. Is you have to turn the switch on.
The light is on now, Chris.
Generally speaking, and we're going to talk a bit about this in a bit more detail later this afternoon, but we talked about kind of the need for interoperability requirements, open standards. How have vendors of these core components, some have been providing these technologies, historically, and some are newer in terms of technology. How have they responded to these needs, and how have they participated in projects like yours?
So I would say that by and large, both the utilities and the vendors have become pretty sophisticated about the issue of interoperability. There are some gaps in terms of standards that are still being worked on, largely because we've been introducing new technologies and new ways of using them, and that's led to the issue of we don't always have the right interoperability standard. But in terms of the need for open standards and interoperability, I don't think there is very much in terms of debate there, and I think the vendors work hard to achieve that. I think the utilities are smart about looking for that as, one of those core best practice checklist items when they're looking at things. So I think it's an issue that's well understood. You can go back a number of years and go back to the early days of SCADA systems. I used to have this slide, I don't use it anymore, but it's a famous painting of the Tower of Babel, and I listed on the sides all these different SCADA protocols. There were dozens of them. They were not interoperable at all. So if you bought one from a particular vendor, that's what you were stuck with, and you had to get all your stuff from them. The utility industry decided that was a bad idea and moved forward to standards. That's why we have things like DNP3 and so on, to resolve that, because everybody realized what a problem that was. So I would say it's well understood as a best practice now, and I think the vendors work hard at that, and I think the utilities understand the issue too. We have some gaps. They're being worked on.
More? Do you have a question? And go ahead, Commissioner, please.
Thank you. Sorry to prolong things. The delivery mechanisms may be the physical attribution of a platform. It may be that manifestation, but underlying the products, the services, the deliveries is data. And meaningful information extracted from the data. Do you conceptualize a singular data warehouse that resides somewhere in a layer on this platform?
I've worked on that from an architectural standpoint since I first started doing this back in 2001. There's no single answer to that. More and more what we see, though, is that the idea of people moving to a combination of centralized and distributed data management. Just like, especially in distribution systems, we're seeing a gradual move from entirely centralized control to a combination of some central and some distributed control. They're almost parallel issues. So I would say, no, I don't think you would necessarily expect to see one gigantic data store. I've seen some projects like that, and it's getting to the point where that's almost very difficult to do because of the amount of data and the various ways it's used and so on. And I think you'll find that various vendors of the multiple platforms that you're going to see in place for a while will each have a sense of doing some of their own. One of the things that we'll talk about when I come back on Thursday is how to relieve some of that complexity, because it leads to a lot of back-end integration problems. So there's a real issue about, how do you manage all of that data? And so you'll see people will come to you with data management platforms. They'll come to you with analytics platforms that also have a data management component in them. You'll see people suggesting, cloud-based data management. So there's a lot of different things, but I don't think you should conclude that the ultimate answer is one gigantic centralized data store.
Jeff, I like this notion of future-proofing. I mean, who wouldn't agree with that? Who wouldn't agree with that? But if you scratch the surface a little bit, what does that really mean? What kind of questions as a commissioner do you ask in order to fully appreciate or understand whether or not something is future-proofed?
So this can require a little bit of technical analysis, but what you're looking for there is, does it not only meet the immediate needs, but Is it likely that you would have to change it if any small conditions in the immediate needs change? So you're looking for a degree of flexibility in that underlying thing, and you're looking for a degree of layered isolation too. So, for example, if you have a set of applications, a communication system, and an electric infrastructure, you may have to change things at any one of those layers. And what you'd like to see is that your platform or whatever you're using does not propagate those changes up and down across those layers, because that's how you get into the non-future-proof scenario where, well, you know what, I was using a particular kind of communications technology that's become obsolete and I have to replace it. If replacing it implies that you're going to have to change all the stuff above it to a significant extent, that's how it was not future-proofed. If, on the other hand, the communications network was supporting a variety of open standards, so that you can say, I can change out that communications layer and everything above it's going to be transparent to that layer above it, that's an example of doing the future-proofing. So you're looking for that sort of isolation effect that says, if I make changes in one thing, are they really going to ripple through, or are they not going to ripple through? That's number one. Number two, is the stuff that this is being built on look like it's persistent, or is it stuff that we're seeing that changes every year or every couple of years? You know, some technologies are like that. They change pretty fast, and in the utility world, we kind of don't like that too much. You know, power transformer has a 40-year design life. They run them for 60 years. You know, the old story, distribution engineer comes in out of school and given the job of handling a power transformer, and success in his career as he retired, and it never had to change. He didn't break it. That's sort of the old model, and with all of this new technology, it's not quite like that. Things do change, and we have to face the fact that some of this is going to change faster than the old utility model. But we'd like to see some things that we have reasonable justification to believe they're going to be persistent for a while, so that they aren't going to be put in place, and then 3 years later, long before the value's been extracted out of them, we're saying, well, that didn't work out, we have to rip it out. And sometimes you can get at that by looking at how much flexibility there is. You know, some of the older approaches to doing communications didn't have the ability to expand from being AMI networks into being distribution automation networks. So you kind of got this stranded effect there where now that we want to move into distribution automation, that communication network that we thought would serve that purpose doesn't, so we've got to spend more money on another one. So looking for that capability down the road beyond the immediate need is a part of how you think about that. You know, what's the next thing that's going to have to support, and will it do so, versus is it only going to do this thing that's right here? And that has an impact on how you think about the cost of the systems too. Because if you think about, well, the immediate cost versus the life cycle cost, given that there are going to be more things you want to do, you kind of get potentially different answers about what you want to invest in. I hope that was a little bit helpful.
Very helpful. Jeff, as always, thank you very much. Extraordinarily helpful to us. We really appreciate your presentation, and we look forward to hearing from you at the end of the phase. So thanks to Jeff Taft. Okay, we are going